Hi children, we continue with the fourth chapter, carbon and its compounds. Now we move on to the chemical properties of carbon compounds. So today's topic is chemical properties of carbon compounds. Chemical properties of carbon compounds. There are four chemical reactions that you have to learn under this topic. The first one is combustion. So in 8th standard we had a chapter named combustion and flame. I hope you remember. What is combustion? It is a process, chemical process in which a substance reacts with oxygen, giving off heat and light. This is known as combustion, a chemical reaction in which a substance combined with oxygen giving off heat is known as combustion. Most of the combustion reactions light will be produced, but it is not mandatory that light is produced in combustion. Heat is produced, that is compulsory. All combustion reactions heat is produced, but in 99% combustion reactions heat is also produced light is also produced along with heat. Okay. So carbon in all its allotropic forms burns in oxygen to give off carbon dioxide, heat and light. So carbon in all its allotropic forms burns in oxygen to form carbon dioxide with the carbon dioxide along with the release of energy in the form of heat and light. And most carbon compounds also upon burning in oxygen release heat and light. So this is the reason why carbon and its compounds find application as fuels. So that is a question. Give reason why carbon and its compounds find mainly used as fuels. So reason is carbon in its allotropic forms, carbon in all its allotropic forms burns in oxygen to release carbon dioxide along with the release of energy in the form of heat and light. Most carbon compounds also burns in oxygen releasing energy in the form of heat and light. So elemental carbon combines with oxygen, you get CO2 plus heat plus light. Then a carbon compound, methane, the simplest hydrocarbon, methane, when it burns in oxygen, again it produces heat, carbon dioxide. Carbon will be oxidized to carbon dioxide, hydrogen will be oxidized to water vapor, then heat, light. Another compound of carbon, ethanol, CH3, CH2OH. This is ethanol. We have learned ethanol. When it burns, it combines with oxygen, again changes to carbon dioxide, water, heat and light. So carbon in its elemental form and also in the form of its compounds burns in oxygen producing energy in the form of heat and light. That is the reason why carbon and its compounds are mainly used as fuels. That is the question. Now we have saturated hydrocarbons and unsaturated hydrocarbons. I hope you know. Saturated hydrocarbons are hydrocarbons in which we have only single bonds between carbon atoms. Unsaturated hydrocarbons are hydrocarbons in which there is a double bond or triple bond between carbon atom. So saturated hydrocarbons burn with a clean blue flame. What do you mean by clean flame? What is the meaning of clean? No soot is produced, non-sooty. About soot we have learned in 8th standard. Soot is that black residue, curry, that is deposited on objects, they are placed in the flame. So saturated hydrocarbons burn with a clean blue flame, non-sooty blue flame. Unsaturated hydrocarbons burn with an yellow flame with lots of smoke, producing lots of smoke. This is a yellow flame is sooty flame. Sooty means the flame that produces black residue on the objects placed in that flame, curry. So yellow flame is sooty flame, blue flame is clean flame, non-sooty. Okay. So this is actually used as a test to distinguish between saturated hydrocarbons and unsaturated hydrocarbons. Saturated hydrocarbons burn with a clean blue flame, non-sooty flame, whereas unsaturated hydrocarbon burn with an yellow flame producing lot of smoke. So, it is sooty flame. Now, when is a flame produced? What type of substances burn with a flame? Some substances burn with a flame like a candle, then LPG, kerosene, all these burn with flame. Substances like charcoal, coal, etc., they do not produce flame. Initially, they will glow in red color, then they burn without a flame. So, some substances burn with a flame, some burn without a flame. Only those substances produce a flame which vaporize on burning. Upon burning, some substances vaporize. So, flame is produced only when gaseous substance burn. So, even without vaporizing also heat is produced. Coal, charcoal, etc. are also used to produce heat, but they burn without a flame because they do not vaporize upon heating. They do not vaporize on heating. So, they burn without a flame. Substances that vaporize and produce gaseous substances upon heating, they produce a flame. Okay, so, there are substances which burn with a flame. Those are substances which produce vapors upon heating. The substances that do not produce vapors burn without a flame. Coal, charcoal, etc. are examples of substances that burn without a flame. So, this is combustion. What is combustion? Combustion is a chemical process in which a substance reacts with oxygen to produce heat, to give off heat, is known as combustion reaction. Carbon in all its allotropic forms burns in oxygen to produce carbon dioxide along with the release of heat and light. Most carbon compounds also produce heat and light upon burning when they combine with oxygen. So, the equations you have to learn: carbon changing to carbon dioxide along with heat and light, methane, then ethanol changing to, this is methane, CH4 is methane, this is ethanol changing into carbon dioxide and water vapor along with the release of energy. Okay. Then a test to distinguish between saturated and unsaturated hydrocarbon. Upon burning, saturated hydrocarbon produce a clean blue flame, non-sooty flame. Unsaturated hydrocarbons produce yellow flame with lots of smoke. Okay. So, this is a test for identification of saturated and unsaturated hydrocarbons. So, next reaction is oxidation reaction. Oxidation reaction. What do you mean by oxidation? Addition of oxygen to a substance is known as oxidation reaction. Gain of oxygen or addition of oxygen to a substance is known as oxidation reaction. Actually, combustion is an example of oxidation reaction. Combustion, substance is combining with oxygen. Oxygen is added to a substance. So, combustion reactions are examples of oxidation reaction. But here what we are going to learn is oxygen is added not directly. It is not combination with oxygen. Plus oxygen will not be there. Instead, we make use of a substance known as oxidizing agent, which can provide oxygen needed for oxidation. We make use of a substance known as oxidizing agent like alkaline, potassium permanganate. Potassium permanganate you have learned in 9th standard. Alkaline potassium permanganate is written as, in the equation it will be written as alkaline KMnO4. What is the color of potassium permanganate? Purple. It is a purple colored liquid. Another oxidizing agent that can be used here is acidified potassium dichromate. So, it is written as, in the equation it will be written as acidified, the formula is K2Cr2O7, acidified potassium dichromate. It is an orange colored liquid. Okay. So, here oxygen is not directly added to the substance. Instead, oxygen is supplied by another chemical substance known as oxidizing agent. The common oxidizing agents that are used here is either alkaline potassium permanganate KMnO4, which is purple in color, or acidified potassium dichromate. And these reactions are used to, oxidation reactions here are used to convert alcohol to corresponding carboxylic acid. So, we have to learn oxidation reactions where alcohols are converted to the corresponding carboxylic acids. What do you mean by corresponding carboxylic acid? If you are taking an alcohol with 2 carbon atom, the corresponding carboxylic acid will also contain 2 carbon atom. 2 carbon alcohol is converted into 2 carbon carboxylic acid when it is heated in presence of either alkaline KMnO4 or acidified potassium dichromate. So, an example we will write. First example. Okay, so these reactions are used for the conversion of alcohols to corresponding carboxylic acids. CH3, CH2, OH. The name of this alcohol is ethanol. This is the example that is given in our textbook. So, what are the oxidizing agents used? Either alkaline KMnO4 or you need not take both, acidified K2Cr2O7, and you have to heat it. Whatever be the oxidizing agent taken, you heat it. Alkaline KMnO4 or acidified potassium dichromate, you heat it, it changes to ethanoic acid. Acid with 2 carbon atoms, ethanoic acid. So, you can see that in the reactant there is only 1 oxygen atom, in the product there are 2 oxygen atoms. Oxygen is added. From where did they get the oxygen atom? From where did this ethanol get the oxygen atom? From this, whatever be the oxidizing agent, if it is KMnO4 or dichromate, from the oxidizing agent. You can see that KMnO4 has 4 oxygen atoms, dichromate has 7 oxygen atoms. So, they are capable of giving oxygen for the oxidation of the other substance. So, they give oxygen. So, the compound gets one more additional oxygen, CH3COOH. Actually, in this reaction we are writing alkaline KMnO4 or acidified potassium dichromate above the arrow mark. If you are writing it with plus sign here, in the products also you have to write what happens to this oxidizing agent. Oxidizing agent always undergo reduction. So, what happens to the oxidizing agent? So, in the product side you have to show that. In order to avoid it, higher classes you will learn it. Now, time being you just learn that an alcohol with 2 carbon atom is converted to an acid with 2 carbon atom. Ethanol is changing to ethanoic acid when it is heated with alkaline KMnO4 or acidified potassium dichromate. So, what is the function of these compounds here? They are acting as oxidizing agents. They are capable of adding oxygen to other substances. So, we call them as oxidizing agents. Okay. So, only the change main reactant to main product, that is only shown here. Actually, this compound, they are undergoing reduction, that we need not learn in 10th standard. Okay. So, one more alcohol I will show you. The next alcohol, CH3, CH2, CH2OH. What is this? This is propanol. Alcohol with 3 carbon atoms. So, alkaline KMnO4, then heat. Instead of this you can use acidified potassium dichromate also, but you have to heat with it. Only one is needed. Please do not write both. Only one oxidizing agent is enough. So, what will happen to it? CH3, CH2, COOH. Propanoic acid changes to propanoic acid. Alcohols change to their corresponding carboxylic acid. Ethanol to ethanoic acid, propanol to propanoic acid. Sometimes the question will be, how will you convert ethanol to ethanoic acid? Then what you have to write? Ethanol is converted to ethanoic acid by oxidation with either alkaline KMnO4 or acidified potassium dichromate. It is heated with either alkaline KMnO4 or acidified potassium dichromate. Then it changes to ethanoic acid. Equation also you have to write. That is how question come for the board exam. Okay. So, I hope it is clear to you now. So, that is all for today. Thank you, children.